Get started on DC motor control. Okay, if we have a DC motor, and let's just assume this is a DC brush motor with a permanent magnet inside. The question is how to run this DC motor. And there's a very bad idea to run this motor. Let's see, we have a very to run it, and that is you connect the motor. Let's say we assume this motor has a nominal voltage like 3 volt, and you can connect the positive end of this motor. Oops, something wrong with my iPad. The positive end is connected with your Raspberry Pi, the GPIO pin, and the negative end is connected with ground. So this is a very bad idea to run the motor. As we all know, your Raspberry Pi probably can output 3.4 volt. However, it is not a power source to power a, especially for DC motor that consumes a lot of power. So even the voltage probably can run the motor. So motor nominal is 3 volt, but the current is too slow. So if you try to run motor like this, you're gonna run into very slow current. It's not enough to run a motor. Usually, you need hundreds of milliamps to run a motor, and for Raspberry Pis, the GPIO pins can only output probably 20 milliamps, I guess. So this is a bad way to run the motor. And a better idea to do this would be you still have your Raspberry Pi, but you use that to control a switch. And the switch, one end of the switch is connected with a power source, let's say V plus. Let's call this switch S1. And the end of the switch is connected with your DC motor and ground. So let's look at this. This is a much better idea, since you can use a Raspberry Pi to write a program to close the switch or open the switch in order to control how the motor is running or cut it off. Let's look at a situation that your motor it's been running, so that when switch is closed and suddenly you want to open the switch to reduce the current flow into the motor, now what would happen? Would we run into any problems? So you probably don't know. You think, I don't know what the answer is for this. But if we look at the DC motor equation goes Vm, that's the voltage of the motor, goes K, that's the torque constant, times omega plus IR, plus IL times di dt. So this is a motor, DC motor equation. And what happens if we suddenly decrease the current? Just by looking at this equation, what would happen? What's your prediction? Let's see, suddenly decrease current to 0. when you open the switch. Usually, in this term we have current. In this term we have current I. If current goes to 0, and this term will goes to 0, so that won't change a lot. But if you look at this term, so if you suddenly change current to 0, and what's the change of this? So how fast current is changed, DITT. So that goes to very large. DIDT gonna be infinite large. Just remind you that this term L times DIDT is because it's the inductor instead of DC motor. That's the equation for inductor. And so this term goes to very large. That will give you a very, so end up with very large voltage. And so if have condition that when you try to switch off, you're gonna have very large VM. So what happens if you suddenly have a very large voltage? So the consequence is gonna be you're gonna see spark, arc. So this is bad. See spark or arc when you try to switch off a motor. That can be dangerous. That can damage the components. And so this SI can be, the switch can be either a relay or transistors, like MOSFET transistors. So if you're using relay, that spark and arc can fuse the relay to cause the permanent damage to the relay. So it can be quite dangerous. How can we control diagram to avoid this spark and arc? So one way we can do is by simply adding a diode. Can add a diode here. And to get rid of this large voltage rise when you switch off. So this is also, this diode has a name in this circuit. It's called flyback diode. So why by adding this diode we can get rid of the spark? So first, it allows current to flow. Like I said, when you switch it off without this diode, and the current changes from a certain value suddenly to 0, so that would get this term increased to a very large number. And by adding that diode, you keep the current flow. So kind of to get rid of the sudden increase of voltage there. And another function of this diode is force the voltage cross motor to be 0.7 volt. As we learned previously, a diode would have a forward bias voltage drop that's about 0.3 volt, right? So once you have add that diode with the motor, that one end of the motor is connected to the ground. So we know here we must have 0 volt, 0 volt. So at that point is 0 volt. And if the across the diode 0.7 volt, so at this point, let's call this point A, VA has to have a negative 0.7 volt current. So this kind of, by adding this diode, you're forcing this motor to have 0.7 volt. 0.70 volts, so cross the motor is 0.7 volt. Sorry, this is negative. So that's kind of the purpose. It's a very smart way to adding a flatback diode to enforce the voltage cross the motor to be negative 0.7 volt. So with adding this flatback diode, the current change is much smoother. The dt become to 0.7 volt minus IR divided by L. That's come from the motor equation. Oops, something wrong here. Take it out. If we want to draw the current profile gonna look like I. This is T time. So at the beginning, if the motor is running at a steady state, which is constant current, and when you try to switch off, let's call this T1. That's the time you want to turn off the motor, and the current gonna change like this. If you have the flatback diode. If imagine if there's no flatback diode, your current is gonna change dramatically like this. So by adding that diode, smooth out the current increase after you open the switch. Okay, let me reboot this app. I think it crashed. Oh, now we're good. Okay, and so that's the most basic way to run a motor. And last time we mentioned the PWM, and we'll talk a little bit more about PWM. So you can use your Raspberry Pi to send out a PWM to the switch to control the motor so that you can control the speed. Here, this method we have here can only turn on and off the motor without control the speed. So to control the speed, use PWM. Oh man, something wrong with this app. Okay. So if you want to run the motor in high speed, or high power, you can send out a, excuse me, what's going on? You can send out a PWM wave with large duty cycle. That's when you want to have a high speed, high power output from the motor. So the duration of this one high power It's your duty cycle. If you want only run the motor at low speed and low power, you can reduce you can reduce the duty cycle, make it very thin. So the duration of your high power can be very thin. In this case, you're going to have a smaller um, power output in your motor. And so this PWM is controlling the average voltage. By adjusting the duty cycle, you're controlling the average voltage on the DC motor. Your average voltage is changing between 0 to Vm. And also another parameter is important for PWM, that is the frequency. Frequency is defined by 1 over T, that is F. So this F is really the frequency between 10, really between 10 kilohertz and less than 40 kilohertz. So that tells you you cannot have a very small frequency from your PWM. Can also couldn't have a very high frequency to control the motor. So why is that? If you have a very low, like smaller, let's say smaller than 10 kilohertz. Let's use the extreme case. What if your high pulse, the time duration between your high pulse, let's see, this is the timeline. Let's see, this is 1 minute. So the frequency is very low. And what if you only have send out a pulse every minute? And what would you see on the motors? You will see motor runs for a short time and it will rest for another minute until the next run. So you will see this discontinuous running from the motor. It's caused by this low motor. So the motor will stop, low frequency PWM. Motor will stop, and there's not, because there's not a very good average voltage. And what happens if you have a very high frequency? That could cause some problem as well. So if you have very high frequency, let's say higher than 40K hertz, then if we go back to the circuit, in the circuit we have this switch S1 and we have that diode. So that would lead to a problem for the switch. The switch S1 has to be very high frequency switch. That could means higher cost, right? And also your diode, flat back diode, gonna have a higher requirements to fit for the high frequency. So you need to use a special diode if you have very high frequency. The regular diode and switch not work if you have such high frequency. Okay. That's about very brief about PWM to control speed. Remember, the frequency of PWM is very important. Next thing, I think during your presentation, someone mentioned control direction. How to control direction of motor. You can use H bridge, and a H bridge has 4 switches and 4 diodes. So you have connect diode, diode, 4 open. And at the same time, you have 4 switch. Let me connect them first. Okay. So let's see, you have S1, S2, S4, S3. And your motor is in between. It's at the center here, motor. And on the top of the bridge, connect that with the power source. At the bottom of the bridge, connect with ground. So what H bridge does is you can, every time you control 2 switches out of the 4 switches, then you can control the direction of the motor. For example, if we switch, keep the switch closed for S1 and S4, and keep other 2 switches open, and how the current will flow. So imagine S1 and S4 are closed. So the voltage current will come from here and go through this S1 and go through the motor and go through S4 and go to the ground. So this will give you forward motion. Similarly, you can close the switch S3 and the S2 at the same time, but close S1, S4. And let's see how the current will flow. So current will flow from the voltage source, go through S3, come here, diode that couldn't run, so go through the motor, and all the way come to S2, goes to ground. So in this condition, you will have reverse motion. So what happens if you close S1 and S3 at the same time? So let's say if we close S1 and S3, current come from, and it couldn't flow back to the ground. So this will give you break because there's 0 voltage close motor. This is also called dynamic braking. And since we just talked about when you have S1, S3 that is closed, now what happens if you have S2 and S4 closed and have S1, S3 open? In that case, you will also have brake mode, which is dynamic braking. So here there are 4 different motions you could have, 3 actually: forward, reverse, and brake. And another condition is what if you only have 1 switch that is on? Or you can have none of the switch. Oops. None of the switch is on. Under this case, the motor is coasting since there's no current flow. And there are some other cases. That is the case we don't want to see. Is when you uh, has have S1, S2 close. What will happen if you have S1, S2 close? Current come from voltage source, go through S1. Since S2 is closed, you cannot short the motor. So the current will go into the ground directly. So that's a short circuit. So both if you close S1, S2 or S3, S4, this will give you a short circuit. So it's very bad. You want to have that to happen. Bad. Okay. And so you don't have to build your own H-bridge. You can usually buy them as a package. And but when you buy it, make sure you look up their data sheet. Make sure they have the diodes and flatback diodes built into the package. Otherwise, you have to connect them on the external circuit. Okay. All right. All right. That's pretty much about DC motors. And there's something extra I would like to mention is and DC motor has a very long history. Oh, I shouldn't say DC motor. Let's change this. Okay. I think this app has something to do with the black color. Every time I choose black color, it just wouldn't allow me to switch pages. So, okay. We should say electric motors. Electric motor has a long history. So some important people who are involved in electric motor development going to be Ferrari. You probably hear that. There's a car company, it's called Ferrari. In 1821, it demonstrated the magnetic field around the current carry wire. So that's kind of the most important discovery. That is magnetic wire has current flow. So that's kind of the most basic basics of electric motor. Then it's further developed by Henry in 1831. So this guy built the first rocking electromagnet. If you're interested, you can search or Google what they did. Okay, then, but we don't have motor yet, and until this guy is called Surgeon, I guess. In 1832, he invited the commutator and rotational electric motor. That's kind of the time when first time we had electric motor. We mentioned commutator is very important to switch the direction of current, and so this guy invited the first kind of motor. Right, something interesting I'll mention here. I think some of you may have the question, Hey, um, and why Tesla is called Tesla? Why Tesla's name is not here? Let's mention next. So Nikola Tesla um, invited, invented AC motor in 1888. That is AC induction motor. And so that's kind of the timeline of history, how electric motor is developed. And I think interesting thing is that's why Tesla, the car company is called Tesla. It's because Tesla cars, they use AC induction motor instead of a DC motor. That's why they use the name Tesla from Nikola Tesla. And there's another electric car company is called Ferrari. It's a very new company. I'm not sure if their products on market yet. Um, they pick Ferrari as their company's name, and I guess they're using DC motor. And since here we're talking about mention AC motors, we're not going to dig into the AC motor, but I want to just give you an overview. What are the pros and cons for AC motor and DC motor? So why um, after this and kind of like overview, you probably can get an idea why Tesla probably choose AC motor for their car. But the majority of the electric car companies are using DC motors. And I think another reason Elon Musk chose Tesla, that's just my own words. I think um, Nikola Tesla, it's a golden bachelor, it's a very smart guy back in time. I think Elon Musk just think he's like him, maybe. So let's look at the pros. So what are the pros cons of DC motor and AC motor? So for the advantages of DC motor is it, like we said, you just give it a voltage and it runs. They give it a large voltage, it runs faster. So it's very simple to control. That's the biggest advantage of DC motor. And it's not that expensive. And here what I mean, not it's inexpensive for low power applications. See that? And it is also good for variable speed applications. So far, it sounds like, oh, it's pretty good, simple to control, inexpensive, and good for variable speed applications. So far, it sounds like it's a best candidate for electric cars, right? So you want something easy to control, cheap, and good for variable speed. You're driving your car in different speed. Um, but you will see some disadvantages once we finish what are the points for AC motors. For AC motors, um, the biggest advantage of AC motor is high power factor. And also it has a very long life. And it is very good for fixed speed application. So now you can see why Tesla may choose they choose AC motor for electric car for their cars at least. And the high power factor can be very good for to provide a very high torque for accelerations, for towing a trailer, stuff like that. And long life, I think that's the biggest advantage for AC motors, since you want to have the motor last long without breaking down. And this good for fixed speed application. It sounds like not very good for car applications since the car is running at different speed. But by adding a gearbox, this problem can be easily solved, right? Now let's look at those are the points of for DC motor and AC motors. Let's look at the other disadvantages of each motor. So the one of the problem of DC motor has a short lifetime compared with AC motor. It has relatively shorter lifespan, and it also excuse me requires high maintenance cost, and especially for brush DC motors, the brush has to be changed um, every several years, and it'll be better for brushless motor. And another disadvantage of DC motor is it has low power. That's why I think earlier when electric car was not that popular, people would think, oh, electric car are very sloppy, um, like they mostly used in the golf cars, very slow, low torque. But that's why people have that impression on electric cars. Um, but it does have lower power than um, AC motors. And let's look at those are the three corners for DC motor. Let's look at what are the disadvantages of AC motor. And first one is um, more complex control. Like we mentioned for DC motor, it's very simple to control. For AC motors, it's not that easy, and it takes more to control AC motor. And but as you know, control can be done through softwares, right? Can be improved by softwares, which is cheaper than hardware. And another disadvantages of that is poor low speed control, low speed performance. And that's why it's very poor precision control. And for poor precision control, I don't think that's a big problem for electric car applications. But this poor low speed performance, this can be overcome by using gearbox and some advanced control strategy. So here's kind of a big picture about what's the pros and cons for DC motor and AC motor. And hopefully that will help you to choose your future project if you want to have any future project. Yeah, that's pretty much it. Let's see if I have any other things. And I think for this class, and for most of your home projects, and you probably would choose DC motor. This is easier to control and it's cheaper. And and it's easier to have DC power from batteries, right? So just be careful. Um, there's something I think for DC motors, voltage is not that important, but current is very important for DC motor. You have to make sure the current goes into your DC motor is less than the maximum allowed cover rating from the data sheet. So you have to make sure the current is smaller than the rated current. Otherwise, it's going to burn your DC motor. And that damage is irreversible. And another problem for DC motors is you need always keep an eye on the overheating. Make sure your motor is not overheating. And since that can also cause permanent damage to the motor. Yeah, that's it.